Good afternoon. Welcome to this first Period 6 session. This week we are going to look at calculations involving percentages with a calculator. We've noticed that whilst many of you are really good at working out percentages without a calculator, you're not particularly confident, some of you, with the techniques that involve a calculator. And so that's what we're going to do. You all need a copy of the attachment that I've either attached to class charts or hopefully you've got in front of you if you're in school. And we're going to start by just doing a little bit of percentage to decimal conversion. So I'd like you to set out tables like this. 23% as a decimal is 0.23. 102%, well, that's more than we started with, so that's 1.02 as a decimal. So I'm just interested to know if you can fill in the other decimals in that table. Press pause and have a go. Okay, here are the answers. So I wonder how you wrote 70%. Did you write it as 0.70 or 0.7? Both are correct. We don't need the extra zero, but if it helps you, that's fine. Only one decimal point in this one, so it's not 0.01.5. It's just that. And these ones again, 120. I don't know how you wrote it. Either is okay. This is the best way. And 102.5%, again, no double decimal point, it's just 1.025. And I don't know whether you spotted that if you wanted to change a percentage to a decimal, you just divide it by 100. Now, most of you don't need to do that. You can sort of do it in your head without thinking. But if you get one that you're stuck on, just divide it by 100. And if you remember, that means moving the digits down or to the right to decimal places. Okay, so we're now going to go through a number of techniques which we can use a calculator for. I'm going to go through an example, and then you're going to all try one or two questions from the sheet which I've attached to class charts, and those of you in school have a copy of it. So here's the first one then. 12 out of 40 students forgot their homework. I want to write this number as a percentage of this number. So we're writing one number as a percentage of another. Really easy process. Firstly, write it as a fraction. If I didn't have a calculator, I would perhaps try and cancel that fraction and do this process manually. But with a calculator, easy peasy. I'm just going to type that fraction in, either as a division sum, 12 divided by 40, or I'm going to use the fraction button, 12 over 40. Both give me the same answer, but what I need to do is press the S to D button to change that into a decimal. And then hopefully, based on what we did just a second ago, you can tell me what 0.3 is as a percentage. It's 30%. Remember that process, you're multiplying by 100. So on the sheet, see if you can have a go at question A2. Press pause and have a go. So in question A2, Rosie got 41 out of 45. Now when I do that on my calculator and press S to D, I get 0.91 with a dot over it. So it's important to remember that that actually means 0.91 reoccurring. And so as a percentage, that's 91.1 recurring percent. So 41 out of 45, 0.91 recurring, 91.1%. So here's the second technique, finding a percentage of an amount. Now, in my experience, most of you are really good at doing this without a calculator, by building up the percentages we want, working out 10%, 5%, 1%. It's really, really easy with a calculator though. So 72% of a class of 200, all I do is I change 72% into the decimal equivalent using what we did at the beginning. So that's 0.72. And I do 0.72 times 200. And that gives me my answer. So 0.72 times 200 44. So have a go at question A3 on the sheet, press pause and have a go. So hopefully you did 15% is 0.15 multiplied by 80. Now you're probably thinking, well, hang on a minute, I could do that really easily without a calculator. Great, but it's super quick with a calculator, and of course it's really useful if the percentages and the amounts are a little bit harder. Okay, so now we're going to look at a really, really important technique. That's increasing or decreasing by a percentage. Percentages are often used to describe a change in an amount. So let's firstly increase £300 by 7%. Again, you could do that on your calculator without your calculator, but I want to do it with a calculator. It's super easy and super quick. So I'm going to firstly say, okay, this amount I start with is 100%. I always start with 100%, and I'm adding on 7%, so I've got 107%. I'm trying to work out what 107% of this is. So I take the decimal equivalent of 107%, which is 1.07, and I multiply it by 300. So 1.07 times 300 gives me my final answer. I haven't got to add anything on or take anything away. That's my final answer straight off, £321. If I want to decrease something, well, I start off in the same way. That's 100%. But this time I want to take away 11%. So that means I'm going to be left with 89%. So I want to work out what 89% of this is. So I use the decimal equivalent of 89%, 0.89, and multiply it by 300. So here we go, 0.89 multiplied by 300. And that's the final answer. I don't have to add anything or take anything away. So I call this the multiplier method. So this is the multiplier you use to increase by 7%, and this is the multiplier you use to decrease by 11%. An increase will mean a percentage that's greater than 100, 1 point something. A decrease will mean a percentage that's less than 100, 0 point something. So on the sheet, see if you can have a go at B2 and B3. Which practice those two skills. Press pause and have a go. Okay, so in B2 I had to increase the population by 8%. So I did 100% plus 8% is 108%, which as a multiplier is 1.08. So I multiplied the population by that to get the new population, and because we're talking about people, it made sense to round that to the nearest whole number. B3 was a decrease. I had to decrease 180 by 20%, so I did 100 take away 20, which is 80. The decimal equivalent of 80%, 0.8 times 180, gives me 144. Well done if you got those right. Now the last technique, we were asked to either increase or decrease something by a particular percentage. But what if we know the before and the after, and we want to know what the percentage change was? So in this case, I was 192 centimetres tall. That's my before. And I'm now 196 centimetres tall. What is the percentage increase? And I always do this one way. There's a couple of ways you could do it, but I always do it this way. I always work out after divided by before. The other way is to work out the change, but I think it's easier just to do after divided by before. So I'm going to do 196, which is my new height, divided by 192, which is the height originally. Got to get that the right way round. Got to be after on the top and before underneath. So let's do 196 divided by 192. And S to D that, and that gives me 1.02083. So I'm going to round that. I'm going to round that to 3 decimal places. So that's 0, 2, 0, but the next digit's an 8, so that's 0, 2, 1. So that's 3 decimal places. So that means that the multiplier is that. Now think back to what we did a moment ago with percentage increase and decrease. What would the increase be if I'm multiplying by 1.021? Hopefully you can see that that's a 2.1% increase. It was 100%. If you multiply by 1.021, that means you've got 102.1%, which means it's gone up by 2.1. So have a go at B1 on the sheet. I really like my bubble diagrams, so why don't you try and do one of those for that one. Okay, so last year she scored 8 goals. This year she scored 13 goals. So after divided by before gives me 1.625. That's the multiplier, which is a 62.5% increase. Now often percentage changes happen again and again and again. Sometimes things increase repeatedly. So if you put money in a bank, you tend to earn interest on that. That's the bank saying thank you very much for leaving your money with us. Unfortunately, interest rates are very low at the moment, so you don't earn a great deal. Certainly not as much as we used to. And then sometimes things lose value. So for example, we've already talked about a car. Things like cars and other expensive items tend to lose their value every year a little bit, so that gets repeated again and again and again. So let's have a look at these two examples. This is a percentage increase that's happening 3 years. So the bank says every year we're going to give you 2% of what you've got in the bank as a thank you, and you keep the money there for 3 years. And the key point here is that that is not just a 6% increase. It's not just 6% of this, because at the end of the first year, you've got a little bit more money in the bank. You've got 2% interest. So your interest the year after will be a little bit more. Not much, but a little bit more. And then the interest the year after that will be a little bit more again. So we have to do it year by year. But it's not as bad as it sounds. So a 2% increase, so 100% plus 2% is 102%. So my multiplier is 1.02. So every year I need to take the amount of money I had in the bank, which is 4,500 to start with, and multiply by 1.02. So that's how much I've got after 1 year. What I then need to do is take that new amount and multiply by 1.02 again. That's how much I've got after 2 years. And then multiply by 1.02 again. That's how much I've got after 3 years. Now it doesn't want that answer after 1 year, it doesn't want that answer after 2 years, so I don't need to work those out. It wants how much I've got after 3 years. And you might be thinking, well, that's a lot of work. So what you can do is, if you're confident with your calculator, is you can use the power button, because what we're doing is multiplying by 1.02, multiplying again by 1.02, multiplying again by 1.02, so that's 1.02 to the power of 3. So here we go, 4,500 multiplied by 1.02 to the power of, that's the power button there, and because this is money, I'm going to round it to 2 decimal places, so that's 44p. So that's a repeated increase. If you're not confident with your calculator, you can do it that way. You'll get exactly the same answer. Here my car is losing 30% of its value every year. So every year you start with 100%, you take away 30%, you've got 70% of what you started with. So the multiplier for that is 0.7 or 0.70. So I start with £8,000. At the end of the first year, that's how much it's worth. Don't want to know that. I want to know how much it's worth in 2 years' time. So I multiply by that again. Or I can use the power button and do it that way. So here we go. 8,000 multiplied by 0.7. Well, I can either use the power button or the squared button this time. Same thing. And that's how much it's now worth, 3,920. Note that that's not the same as 60%. It's not just 2 years of 30%, so you do 60%. You've got to work it out year on year. So see if you can have a go at C1 and C3 on the sheet. So these were tricky, these ones. C1, the percentage interest was 2.5%. So 100 plus 2.5 is 102.5, which as a multiplier is 1.025. So for 4 years, that's how much you start with. So you multiply by 1.025, and then 1.025, and then 1.025, and then 1.025, or you use the power button, and then I rounded it to 2 decimal places. That's what we would always do with money. C3 used a key word, depreciate. So if something depreciates, it's losing its value. So this is a repeated percentage decrease. Every year it loses 12%. So every year you get 88% of what you started with. And as a multiplier, that's 0.88. For 5 years, then you're going to multiply the original value by 0.88 to the power of 5. Again, I have rounded it to 2 decimal places. Final technique, and these I think are the trickiest, not because the sums are hard, but because they're hard to spot. So do you remember we talked about before and after questions when we were working out what percentage change? Well, reverse percentage problems are problems where you are given the after and you've got to work out the before. So here we've got a car that costs 12,500 after they've added on 20% VAT, and they want to know what did it cost without VAT. So this is the after price, and I want to know the before price. So my first question is this: what did they multiply by to increase the original price by 20%? So 100% plus 20% is 120%, which is 1.2 or 1.20. So they will have taken the original price and multiplied it by 1.2 or 1.20 to work out the new price with VAT included. VAT is a tax that gets added on to the price of a lot of things. That money goes to the government, pays my wages, and pays for hospitals and all sorts of other things. So, so 12,500. So the question is, how do we work backwards? And what we don't do is we don't take 20% of this off, because it wasn't increased by 20% of this, it was increased by 20% of this. Instead, we just ask, what's the opposite of multiplying by 1.2? And I hope you can see that it's dividing by 1.2 or 1.20. So on my calculator, I just do 12,500 divided by 1.2 or 1.20. And that gives me £10,416. 0.6 recurring, so that's 0.66666, which I rounded to decimal places, is 67p. So those are reverse percentage problems, and they are really hard to spot. So see if you can work out the answer to D1 and D3. So D1, we're told that prices in a particular shop or were reduced by 25%. This is the price after that reduction. What was the original price? So I've got to think, okay, they took prices which were 100%, they took away 25%, which leaves me with 75%. So they will, in the shop, have gone round and multiplied everything by 0.75. So I need to do the opposite. I need to divide by 0.75. So I do 442 divided by 0.75, and that gives me £589.33 if I round to 2 decimal places. D3, prices have been increased by 20%. So they started with 100%, they added on 20, so that's 120. So their multiplier is 1.2 or 1.20. So the opposite, the thing I need to do to undo that, is divide by 1.20. So that is 540 divided by 1.20, which is 450. Now I can always do a little common sense check because it's easy to get things the wrong way around. So if prices were reduced in D1, this should be more than this. Yeah, bingo, it is. And here, if prices were increased, this should be less than 540. Bingo. Yes, it is. Okay, so well done. Those are the key percentage techniques, and they all are based around using a calculator and understanding the decimal equivalent of percentages. All the best. Take care.